Okay, so let's get started. We're going to be taking a look in this training module at our custom VCT scheduling once again. We're going to be focusing on looking at logged data in our VCM scanner so we make better sense of this custom strategy that we implemented and brought into our stock equivalent file in that last training module. We're going to be taking a look at drivability and wide open throttle performance so we can see how the scheduling works and some things to note and potential changes you might want to make into the custom VCT schedule based on what you're seeing in some data logs. But this is, again, just kind of building on what we've already talked about and expanding our understanding of this custom schedule. So let's jump in here. We have our file. We've obviously modified that in the last tutorial that's open here on screen. So 2019 Mustang GT manual stock. We've applied the two template files to this, turning off the intake manifold runner control, as well as applying the custom scheduling in our VCT scheduling. Let's go here to our engine tab. We'll go here to airflow. Under intake manifold runner control, we have bypassed this, turned it off. And then under variable camshaft, we've went in here and we've modified map points and our distance tables so that those have been updated to work properly here for this custom schedule. So now what we're gonna do is jump over to our VCM scanner and let's start to take a look at the couple different data logs we have that I have providing from our demo vehicle implementing this custom VCT schedule. Let's look at that real quick. Let's move over here to our VCM scanner software. I'm gonna go up here to File, Open, and we're gonna go and take a look. Let's go to our desktop. Let's go to our HBT Gen 3 folder. Let's go to our sample data logs. We're looking for our custom VCT scheduling logs. So these 4 logs are gonna be representative of what we talk about here based on the demo vehicle and implementing this scheduling. So we see that we have a couple logs here of note. We find that we have a log here, Watt custom VCT log, last VCT log, all working 100%. We see custom VCT schedule test, and then there's another log here, ETC FMEM custom VCT schedule. So I actually went into torque shutdown mode when I first implemented this because we were raising so many IPC wheel torque errors that it went into essentially a limp mode, and this log here caught that. We'll talk about some of the other changes that we actually need to make above and beyond the template files that we've implemented to really make sure that we're doing things properly and to avoid a torque throttle shutdown and not have that situation, and also to make sure that your torque tables, spark timing tables, and speed density tables are at least a good starting point. The way I did this, I just applied the template files and started to log, and I wanted to capture anything that you would potentially run into and then being able to expand upon that and talk about it a bit. This tutorial, we're not going to focus on those. What we're going to just take a look at here is, let's look at this log, custom VCT schedule test. Let's take a look at the drivability, what we're looking at in terms of how it moves through the map points and getting a feel for the scheduling here, this custom scheduling, because we're moving from effectively map points 0 to 26 now to 0 to 6. So we've greatly reduced the logic, and we can see how it moves through the logic programming. So we're going to go ahead and grab this file here. Let's open it up. Now we're going to take our window here. So we have our chart versus time. Now I do want to mention, if we go to File, Open, we are using the Gen 3 main layout. So this is what we want to open here for your template file for the layout so you can follow along. This particular, let's go up here. Let's open this all the way up in our window, and we're going to go here to our third chart versus time. And here we can see exactly what's going on with our VCT scheduling. So let's first start kind of playing this. You can see how I'm capturing idle. So right now I'm idling here about 900 RPM, 1000 RPM. We see that we are in emissions reduction. I do want to mention, when you flash the engine control module, so you're making a bunch of changes, at least on my vehicle, my 2022 Mach 1, I've noticed that it stays in emissions reduction for a decent amount of time. It can hang in there for as much as a couple minutes, and then it moves into optimal stability. I don't quite know why it's stuck in emissions reduction. I'm sure there's a reason for it after a reflash, but you may see similar behavior out of your engine after you've done the reflash. Usually when I reflash it, it does this kind of goofy, but if I shut it off, start it over again, it'll go from emissions reduction, go in there for maybe 10, 20 seconds when a warm engine, and it'll go right into optimal stability, which is the behavior you usually see. So sometimes the reflash causes us to hang in emissions reduction. We can see that in the beginning of the log here, we see emissions reduction. We know we're calling out cam pairing 0 and 0. Notice down here our math channel intake manifold runner control, which we've loaded into the scanner from previous tutorials. It's showing here that we are at 100%. So intake manifold runner control fully open. That's what we'd expect since we've deleted it, and obviously it's recording that position here. So taking a look, as we're kind of just panning through here, again, we see where mode is in emissions reduction. We start to drive it here as we start to begin the log. At some point here, it goes into optimal stability. Now, normally, when we're talking about this, especially when we start to get an air load of something like 0.25 air load, we're starting to give a decent amount of throttle. It should move into best fuel economy. It should not be an optimal stability. However, and I'm going to point out a change here, in my strategy, so my stock strategy, not what I've implemented in terms of the changes, but my stock strategy, the optimal stability max load, the values here above 2600 were actually set at something like 0.3, 0.32. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.